three examples here. And the first example is 2x double dot plus ax dot plus 16x equal to 0. And we are considering initial conditions. Okay? So again, we want to solve for the response at t equal to how much? So how can we start with this one? How do you think?
The characteristic equation?
Yes, we start from there. Okay, so for this one, we don't know this system is, we have three types of the damping: overdamped, quickly damped, or underdamped. This formula is only for underdamped. So if you start with all the questions with this form, then you kind of misleading yourself. Because this equation we've been talking from last time to now is for underdamped, but underdamped is only one of the three possible cases. So we start from beginning, solving the differential equations. So the characteristic equations, for example, say we let xt equal to x pt. So p is our characteristic root, so that is 2p squared plus ap plus 16 equal to 0. So p squared plus 4p plus 8 equal to 0. And how much? P will be equal to 2a minus b plus minus b squared minus 4ac. Okay, so that is the here. Then we do the Rubik calculations. So the calculation will give us is 2 minus 4 plus minus and 1432. So basically from here the number in the square root is negative 16. Negative 16, so that is J4, right? So here we have minus 2 plus J2. So this is the underdamped system. We can do the things here. Okay, so therefore from here we can write it up is we can copy this form here because this is an underdamped system because that is a complex conjugate. Okay, so therefore this is underdamped system. And or otherwise, the other way we can verify why this is an underdamped system. You can start from beginning. And from the beginning, 2x double dot plus ax dot plus 16x equal to 0, you can convert into the standard form. And you compare this one with 2 eta omega n x dot plus omega n squared x equal to 0. You compare the things, and then you can right away determine the natural frequencies and the damping ratio. So from here, you compare omega n equal to square root of 8, and also compare the temperature terms 4 equal to 2 zeta omega n. So from here, you can determine zeta equal to 4 divided by 2 omega n, and that is 4 divided by 2 square 8. So that is 2 divided by 2 square 2, that is 1 over square 2. Because zeta is less than 1, so here we again, using this approach, we benchmark, verify this is an underdamped system. Okay, but anyhow, so here we have the omega n, and so from here, therefore, xt, we can write it up like this form, and let me pick up, how about let me pick up this one, which way? Okay, either way, let me pick up this one. Okay, and for demonstrations. So that is E minus zeta. Okay, so again, exponent is at a rate that is governed by the real part, so that's a minus 2t. Okay, and multiply with C1 times cosine. The oscillation is governed by omega d, and omega d is our imagined part, so that is 2t plus C2 sine 2t. And now we have C1, C2, we can plug in. So right now we have to do a little bit detailed calculations. So here we do the derivative here, get that ready. So now we take the derivative on this term. Right now basically is the partial derivative and then take the summation. So minus 2, E minus 2t, C1 cosine 2t plus C2 sine 2t. And plus the derivative on the second one, E minus 2t times. And derivative on cosine and sine of the periodic 2, then we have 2 on here, minus C1 sine 2t plus C2 cosine 2t. Good. So get this one ready, then we can have the plugging. So here, initial conditions, displacement equal to 1. So we're using the first one. Okay, so plug in here. So when t equal to 0, exponent equal to 1, and 1 multiplied with C1, and when t equal to 0, leaving C1 itself, and when t equal to 0 sine, C2 disappears. So therefore, from here we determine C1. Okay, so let me use the equation 1 and 2. So by equation 1, okay? Very straightforward, right? From equation 2, we plug in a minus 1 equal to x dot. Okay, and so plug in using equation 2. So we do these calculations, and that is minus 2 times C1, okay, and then the second part is plus 2 times C2. Okay, so that means from here minus 1 equal to minus 2 plus 2C2, and so therefore C2 equal to 1/2. So here we solve these equations here. Okay, so therefore x of t equal to exponents minus 2t and cosine 2t plus 1/2 sine 2t. Good? Okay. So we try a different example, the second one.